it's your boy Tricks. Today we're going to be doing another Rust video. So if I just bring up some of the, let me show you guys. There we go. You should be able to see that now. Yeah. So today we're going to be doing Queen Attack, RNA Transcription, and then simple linked list. And then next week we're going to do rectangles and poker because poker's easy. So yeah, let's get started. Let me just pop it in a terminal. You guys won't be able to see that. Give me 1 sec. And there you go. Now you can see my terminal. So, given the position of... Oh yeah, I just need a thumbnail. Key into X system, then Rust, then Clean Attack. Let me just open up Penguin. README. Welcome to Queen Attack on the X-System track. There we are. Given the position of two queens on the chessboard, indicate whether or not they are positioned so that they can attack each other. In the game of chess, queen can attack with pieces, which are on the same row, column, or diagonal. On the chessboard, a chessboard can be represented by an 8x8 array. The row as the rows of a chessboard. Let me just. There we are. The rows of a chessboard are known as ranks and columns are known as files. So if you're told the white queen is a 2,3 and the black queen is 5,6, then you know that there will be stuff like this. So 2,3, 2, 1, 2, 3. Yeah, I mean 1, 2, 1, 2, 3 for the white queen, and then the black queen at 5,6. So 1, 2, 3, 4. Wait, am I reading this wrong? Hang on. 1, 2, 3, 4, 5, 6. Yeah. 1, 2, 3, 4, 5. Okay, so 1, 2, 3, 4, 5. Right. So that'll be along the bottom. And then 1, 2, 3, 4, 5, 6. So white is I don't know how they're reading this. Because that array looks very weird. That normally when you're like doing coordinates, you do it from here, right? So this would be 1, 1. This would mean 0, 1, 0, 2, 0, 3. I mean 1. Along the corridor 0, upstairs 1. So this would be 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, 0, 8, 0, right? So this would be that 0. That's 1, 2, 3, 4, 5, 5, right? And then 1. I mean, this would be 0, this would be 1, this would be 2, this would be 3. So this would be 5, 3. And this would be 0, 1, 2, 3, 4, 5, 6. Well, 0, 1, 2. So that'll be 6, 2. I don't know where 2, 3 and 5, 6 come from. You also be able to answer whether the queen can attack each other. In this case, the answer would be yes. They can be They can because both pieces share a diagonal. Yeah, because there's a diagonal there. Yeah, diagonal here, straight, straight. There's no diagonal here. There's no diagonal here, and there's no diagonal here. Okay, so obstruct chess position, obstruct queen, implement. Okay, construct a chess position struct given the following rank file. The in the position is valid return one. Okay, so okay, well, community solutions are really nice. There we are. So, so up here makes sense. So all you care about in here is that it has two positions, right? Which are just the coordinates. So if you remember a while ago in like one of my really old videos when I was doing Rust, I figured out that for for certain values, like in a struct, if you give them a variable name before the value, then that will assign it to that value. But if you don't give a variable name, like here, where you just have the types here, this will just act like an array in that struct. So this would be position 0, this would be position 1. So inside here, let me just see. There we go. So inside here, they're doing if this if condition just to check if they're actually on the board. So because it's an array, you need to make sure the rank and the file are within bounds of the board. Then file yes, file greater than 7. Just return none. Otherwise, else. You know what? I'm gonna edit this line a bit just to make it more readable. Chess position with rank on the file. So another way to look at this would be like if for this specifically, it would be like if this was a function and all you're doing is just passing the values through, you but inside that function call, you don't need to give it a name for the variables, you just put the types. I feel like that might have been more confusing than me just saying, oh yeah, this just acts like an array. But whichever like makes it easier for you to understand is best. Okay, this just says make a new queen object. So you just make a queen object. Queen with position. And that's all. Did they do anything special to the queen? Oh yeah, they did. You just pass a chess position, which makes sense. So all you're saying is you just want a queen to have a chess position. So they have a coordinate. So because you're passing the position from here to this queen, you're just saying this queen will be at a specific coordinate on board. Cool. And then this contact logic is going to be the bit that messes me up. Okay. So this is saying R underscore A, F underscore A, R underscore B, F underscore B. Huh? Hang on. That's fine. That's basically the same. That's smart. Hang on. Do you want to change it? Yeah, this is more human readable. That's fine. Self position rank file equals self position just rank position other. No. Oh. You know what? Yeah, I'm on track. So this is saying that r underscore o rank um self rank other self rank self file other rank other file, right, is equal to self dot 0.0 self dot 0.1 other dot 0.0 other dot 0.1. So I hope, let me just, yeah, it does. So I hope this makes sense on this line. So basically, you're accessing the object self, right? You're accessing self would be a queen object, right? And because inside that queen object you have a chest position, you're saying, oh, and the chest position doesn't have a variable name. You're saying you want to access the index of the queen to get that chest position, and that chest position has two indexes, being 0 for the x coordinate and 1 being the y coordinate. So you're saying get the chest position's x coordinate and then get the chest position's y coordinate, which would be the rank and then the file. And then you're doing the same thing for the other queen on the board, which will be the other queen's chest position's rank and other queen's chest position's file. Okay, D underscore R. So this is just saying that you're going to calculate the absolute value of minusing the ranks from both and the files from both. And if they're equal to 0, or they are, or the rank and file of the absolute rank and absolute file after doing after minusing each other's ranks and files are the same, then it will say that you can attack. Otherwise, it will say that you can't attack. I'm trying to understand that. So, oh, yeah, that makes sense. So, basically, if if you minus the okay, so for I don't remember which one's rank and which one's file on the board, but for ranks, for let's say rank is the row and then files column. If you minus the ranks from each other, so the rows from each other, well, because they're on the same row, minusing them will just give you 0. And then same thing, if they're in the same file, the same column, minusing them will just give you 0. So if they're 0, 0, that means they're either in the same column or the same row, right? If they're in the same column or the same row, well, that would be in these two cases, same column, same row. Then you know, okay, cool. Because they're in the same column and the same row, they're directly in line with each other, so they can both attack each other, right? Then with dr equals df, I'm assuming that's if they're in different rows and different columns, Because say for example you have 5 and 2 and 2 and 5, taking them away from each other would give you 3 and 3. So because they're both 3, you know that they're diagonal from each other. Because 5 and 2 and 2 and 5 are directly diagonal from each other that you can both attack. Very smart, damn. Let's just do um same rank equals self rank and its other rank dot adds, right? Then let same file equals self file minus other file dot add. This is because you don't care if it's positive or you don't care if it's negative. You only care if it's you don't really care if it's positive or negative. You just want a value. So if it's positive, then it's fine. Then all you're going to do is just check if same rank equals 0. Being then, yeah, again, I'm going to say that rank is the same row. So if they're in the same row, then you know it's a direct attack. Same file equals 0, meaning that they're in the same column so that they can attack. Or same rank equals same file, where in this scenario, same rank and same file wouldn't be that they're on the same position on the board. It would just be that they're opposite each other. And then if I do that, and then cargo test include ignored. Let's see what's wrong. Same underscore. Let me see what's wrong. Oh, it just wants me to use snake case instead of camel case. I've been programming in Java, so it's like, oh yeah, name variables camel case, don't do snake case, but it makes sense. And change the change the no, I cannot. Yeah, let me tab the rank here. So rank there. Come on, give me an sense. Space. There we are. Oh, I need to actually make it first time. There. I mean, same rank, same file. And then let me just change this because I can't be. Whoops. There we go. And if I run the skin, there we go. So submit SRC lib rs. There we go. So if I go to ping attack, my iterations. So done that one. Now all I've got left is RNA transcription and simple linked list. So let's do RNA. Let me download it. So, given a DNA strand, return its RNA complement, RNA transcription. Both DNA and RNA strands are a sequence of nucleotides. The four nucleotides found in DNA are adenine, cytosine, guanine, and thymine. Four nucleotides found in RNA are adenine, cytosine, guanine, and uracil. Given a DNA strand, its transcribed RNA strand is formed by replacing each nucleotide with its complement by using a private field to instruct the public new function returning the option or result. As here with DNA new and RNA new, we can guarantee that the internal representation of DNA is correct because every valid DNA strain has a valid RNA strain. We don't need to return a result option from into RNA. This explains the type of signatures you'll see in the test. Okay. The librs. Okay. Construct new DNA from string. If string contains invalid nucleotides, return index of first invalid nucleotide. Transform DNA into corresponding RNA and then construct a new RNA from string. If string contains invalid nucleotides, return index of first invalid nucleotide. Cool. So, again. Let's do this one because it doesn't change much. So inside here you have DNA dot chars, then enumerate, then map, I can see match the character to A or C or G or C. You want to return OK bracket C. Otherwise, everything else you just want to return an error. Otherwise, you want to return with that index. So let me just change this. Index character character index. There we go. Then after that's done, you want to collect the result as a result of string with the users. And then you want to map this to DNA. There we go. So if I just run a cargo build, that's fine. I just wanted to see that everything's working fine for the new function. Now I just need to fix RNA and then the new for RNA. I mean into RNA and then the new for RNA. So inside out. Let me just so here we take RNA, right? Then we pass itself, access the first index, convert to chars, convert to a character array, sorry. Then we map a nucleotide and then map on each nucleotide for a G to become a C, a C to become a G, a T to become an A, and then an A to become a U. Otherwise, we return unreachable. Then we collect as a whole string. So then if I just I'll go build again. Into RNA, this opening brace matches this closing brace. Yeah. Unexpected delimiter. Where? Oh, what? Really? Yeah. Yeah. Mm-hmm. Yeah. 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 How's that being weird? Hang on. $8.49, yeah. That one. Enumerate. That. Yeah. Match. Character. Yeah. Where did this extra packet come from? I need to. Error. Yeah. Oh, why? Genuinely don't even know what's wrong with you. There we go. That's building now. Only thing I should need to do now is this one. So you want to take RNA, you want to convert it to a character array, then you want to enumerate through each character, then you want to map. You know what? I'm just gonna copy whatever here. Control C, go, then Control Shift, undo, yank, print. I don't know why sometimes it works and sometimes it's like, yeah, no. RNA, that's fine. A, C, G, and then let me just change this to a U. There we go. Correct U size, and then let me just map it to RNA. There we go. And then it builds, test. There we are. And then I can submit. So if I check RNA iterations, it's passing. It's complete. Confirm. Syllabus. And then the last one, simple link list. Copy. Exit. Then okay. Welcome to simple linked list on SSS rush track, whatever. Write a simple linked list implementation that uses elements and a list. I think this is gonna. Oh, I remember this one. This is gonna be a long boy. Yeah. This is gonna take a while. Oh well. Let's have a look at the linked list one. That's not that bad. So in here, so we just went ahead. That's an option with a box that is a node of that key. Inside this, okay, is the node struct anywhere? No, it doesn't have a node anywhere. Node struct. Just making a private struct. Okay. C, and next, which is just the pointer to the next value, which is just option box node C. Then implementing node. Implement C node C. Then you have a new function. C next in box node C. And then you return self. Let me say self with data, and the next value. Well, the data of the linked list of the node, sorry, and then I'll point it to the next node. Okay. Okay. Goes to itself. Go ahead. Of none. Because there's nothing in the list yet. Then you may be wondering why it's necessary to is empty when it can easily be turned from len. It's good, but because len can be expensive sometimes. It's always cheap. Also, ask yourself whether len is expensive for linked list. Yes, len would be expensive because you're always pointing to another pointer. So every time it accesses len, you would need to first find everything, travel every single pointer to find the actual length of your linked list, and then tell you, oh yeah, there's values in this location. So let's say you do len on the linked list here, because it's not all right next to each other in memory in most cases, unless the only variable you're storing in your memory is a linked list and you're not storing any other values, which is probably unlikely, but it could be a scenario, then it'll be fine because it will just point to the next memory location in memory. But if you store anything else while you're allocating or like creating your linked list or whatever, because you're storing multiple variables or values while you're programming, your linked list won't be all right next to each other in continuous memory. So it would be following the pointers to different memory locations where all the pointers will be right next to each other, may be right next to each other, but in some cases the pointers might just be right next to the node in that linked list. So it would have to traverse the whole linked list to figure out the whole length of that linked list. So you'll be wasting CPU cycles just from following that whole linked list to find out how long the linked list is. And if you just want to check if it's empty, there's no point in doing len to find out if it's empty. Just check if there's a value in the first index of that linked list, if there is, which is what this is doing. Just checking if there is a node, if there is a node in the header. If there is, then you know that the linked list isn't empty. If there isn't a node in the if there isn't a node in the header of the linked list, then you know that the linked list is empty because there always needs to be a head. There always needs to be a node in the first element of the linked list for it to point to somewhere else. Because no matter what, a linked list, like when you're traversing a linked list, it always starts from the first node and then moves on. So linked lists are good if you want to keep track of nodes and point to different nodes. But it's bad if you're searching, because you have to search the whole linked list to figure out where the thing you're finding is, unless you provide it a specific index in that linked list to start from. But if you already provide an index for the linked list to start from, there's no point in you actually using a linked list. You might as well just use a normal array or something. But, current node equals and self dot head. Switching between this and MacBook laptop is very funky. I might just change the layout of this so that I don't get confused when I keep switching between the layouts. Well, that's equals current size plus equals 1. Current node equals and x dot x. So just to explain this little code so far, current node is just you getting the head of the linked list, right? Then you're initializing a size to figure out how long the actual linked list is. Then you're saying the current node could be equal to a value x or whatever. So it just stores the current node in x in an option called x, and then it's saying increment the size of the link size variable by 1, and then for X, which you just stored, grab the next pointer and put that into the current node. The current node will grab, so then when it loops again, it will store the next node in X, increment it, then grab the next node from that node and put it into the current node. So now it's saying just checking if there is like data in the linked list, just check if the first one, if there's data in the first node. It's a lot quicker to just check if the first node has data instead of just checking the length of the list, because the length of the list you have to traverse every single node to figure out how long it is. If you just want to know if there's data in there, just check the first node, because if the first node is there, then you know that there might be other nodes. If there's no first node, then there's no other nodes, because all the other nodes are pointed to by the first node. Then you just want to transfer alpha. Okay, and now push. Push is just adding a value to the node, the linked list. So that node equals box, new node, new element, head. Okay. So all you want is just grab. So this takes the first node in the linked list, takes your element, then creates a new node where let me explain this best I can, right? So it takes the first node, so the head of the linked list, right? And your element. It creates a new node where your element is there, and the element that you pass this function will also point to the head of the linked list, right? So that will all be stored inside of a box, which is just a node. Then you're saying self.head now becomes the node you just passed in. So, okay. So this is kind of like pushing. So this linked list, like the way for me to like kind of describe it is it'll act kind of like it'll kind of act like a stack where you have your first element, right? If you push your first element into a stack, then that element is just there. But every time you push new elements in that stack, it always gets stacked on top. And the element that you access first will always be the new element that you just pushed into the stack, right? So because you're adding elements like this, you're basically saying every time you add a new element to this, I don't know why this is. Every time you add a new element, you're saying put it as the first node in the linked list. So I'm very burpy today. So if so go ahead, what is done? So if there is a head, let the head's node, well, just create a node for the head of that linked list. Also head is grabbing the next node. Then you're saying some bracket head node data. I don't know why you would do. You know what? Yeah, I'm going to leave this line out because technically it doesn't affect this head node. If it does, then I'm going to be kind of confused, but it shouldn't. Self.head dot underscore right. If the only reason I would say that might affect something is if you need to move the next node afterwards, like what oh yeah, you're saying you need to move the head of the That makes sense. Never mind me. So again with the stack specifically, when you pop something from the stack, it pops on the top. So you push pop and look at values from the top of the stack. Same thing with the way that this linked list will be implemented. You're pushing onto the list as the head. You're popping from the head of the linked list, and I'm guessing you're going to peek from the head of the linked list as well. Yeah, you're going to peek from the head of the linked list. So then there's rev, and then there's two more functions. Yeah, cool. So rev, I have no idea what rev is. So let's have a look. It doesn't have this must use. Let my rep equals simple English dot that's just creating a new linked list, and then while that bracket x dot pop red dot push x, and then red. So let me look at this. So this creates a new linked list. Then it pops whatever values are in the linked list. New mutable. Interesting. I'm not sure what this verb function does. Let's just do next one. So insert here. So we're saying let my list equals simple linked list then for item in iter. So in the iterator, you want to push the item onto the linked list, and then just return that linked list. And then let me just, because we don't need this. Oh, okay, I know. Oh, what? From let my rep equals make a vector, make a new vector, then while let x from iter, from iterator, from iter, yeah, and then this just changes to into, yeah, for mhm, mhm. I don't know if this is gonna work, but it's built for now. Yeah. What line is that? 69. Ah, whoops. And then complete demonstration of create into four type simple linked list. Oh, whoops. That's new. Ready that? Let me check. Oh yeah. This is on line 77. Yep. Implement T into simple link list. Oh, whoops. Self pop. And then that's on bit 44, 45. Oh, and stuff, stuff, yeah, yeah. Hmm. Oh, what? No, dot. Yeah. Yeah. What do you mean, like, let me just grab this pop. I don't know why this thing would. Oh, bruh. Literally, I was gonna say, Rust, like, compiler, like, the way that they do their, like, hints and, like, warnings and stuff when you're building, and, like, oh, yeah, this isn't working because of this. Utterly amazing. When you go to other languages and you're like, hey, why isn't this working? You'll understand. Like, you in some languages, you'll just get like a stack trace or something like Python, Java, whatever. They'll just give you a massive stack trace. It won't tell you like, oh yeah, try doing this, try doing that. But in Rust, they know their language is hard, so they're like, oh, let's make it like, oh, when you're learning it, we'll just tell you. Most of the time, they'll just tell you how to fix it, and it will be like in these in like highlights. So you just need to read the whole thing. Yeah, cool. Mismatch types. This is saying that oh, this is a mismatch type. So if you look at the code, you'll be like, oh, what's wrong? But it's specifically telling you, help remove this semicolon, and then above here goes this one. Ah, method's not a field. Just add this. Amazing language, genuinely. There we are, and then submit. Variations. Cool. Mark is complete. Confirm. So next time we are going to do rectangles and poker. We're probably going to start with rectangles first and then move to poker, or the other way around. Depends on how I'm feeling next week. But yeah, thanks for watching. If you like the video, please leave a like on the video. If you dislike the video, please leave a dislike on the video and comment down below ways I can improve content on the channel. Other than that, thanks for watching. Enjoy the rest of your day. Subscribe to the channel. Peace.